All right, here today to talk quickly about some underrated security vulnerability classes. So the title says bugs, but it's specifically bug classes. Not really a big deal. I've been a developer, sysadmin, pen tester. I'm a security researcher. I write some open source tools. I publish a bunch of advisories. I do a bunch of conference talks. So quickly moving on. This talk was inspired by a tweet from a German researcher, and it sort of inspired me, that and the responses, to sort of think about what are some of the other underrated vulnerability bug classes and how can we maybe shine some light on them and show, what else is out there. You see a lot of stuff on bug bounty programs, and it tends to be a lot of like XSS, SSRF, same thing, over and over, rinse and repeat. So what are some of maybe some ones that are less known or less understood? So I asked a bunch of people on Twitter and in person, and I got a lot of different responses. Some of them resonated with me, some of them didn't. And so I generally asked them to quantify why they thought that something like cross-site scripting, that's been like number one on OWASP top 10 for such a long time, why they consider that to be underrated. And obviously their answers were a little bit different than mine. And I think that's good, because it's not just me sort of coming up here and representing my view, but I'm trying to represent a broader view, I guess, across the industry. So why do people think that vulnerabilities or specific vulnerability classes are underrated? So one that I got a lot for the cross-site scripting example is that people don't tend to understand cross-site scripting, right? We find it, we pop up an alert box saying, "Oh, we stole the cookie," or alert 1. And that's not necessarily a great impact. And I think that's probably true. The Beef framework's done a little bit to change that, but I think overall, I don't think it's an underrated vulnerability class. Maybe it's an underexploited vulnerability class, which is sort of different. So there's a bunch of reasons why people think it's underrated. And here's generally a lot of them seems to be there's a lack of public examples, or the impact isn't particularly understood, or we just don't see a lot of advisories highlighting this type of vulnerabilities. So it tends to be considered more of a theoretical than a practical vulnerability. So basically, the rest of the talk, I'm going to take 10 bug classes. I'm going to briefly talk about each one, give an example. There's some reference links. I'm going to put this online so you can go and follow the links rather than typing them in manually. And hopefully you'll all get inspired to learn about some new bug classes and go and leverage that whenever you're doing bug bounty hunting or security testing or security research. So I'm going to start with number 1, because that was what John said, and since he inspired the talk, I think we should start with that one. Argument injection. I've crossed out the CWE reference because everyone I've spoken to has a very different definition than MITRE. MITRE basically says an argument injection is when you do a command injection in the argument portion of a command. Whereas everyone I've spoken to who's a security researcher says that no, it's when you use a binary specific command line option to, for example, execute code. So there's a few examples of that. A very old example is the expansion of wildcard file names on Unix, which is almost a forgotten bug class, I think, at this stage. Probably the most famous one is PHP Cgi Argument Injection. And there's a whole bunch of examples of various things you can do with binaries with specific command line arguments at GTO of bins, which is sort of a log bins collection for Linux. But to talk about the PHP Cgi one, it was basically a problem that when you ran PHP as a CGI module, the query string was provided as a command line argument, and you could then reconfigure PHP to allow URL include, auto prepend a file, take that from standard input, and post some PHP in, and it runs the code. So in this case, it's the fact that you can do -d to reconfigure the PHP on fly. Argument injection meets my definition, not MITRE's. So that's fine. The next bug class I want to talk about is logic flaws. And logic flaws is a very broad bug class. It's not really well defined. There's not a great deal of generic overarching material to learn from. You're better off going to Google and finding individual bug or exploits that reference logic flaws. The very typical one is, of course, negative product price manipulation. So if you're in a shopping cart, if you can change the price because it's in an input field or a hidden input field, you can manipulate that. Or you could possibly manipulate the quantity of the product that you want to buy. So rather than saying I want to buy 5 rubber ducks, I'm going to buy minus 5 rubber ducks, which gets multiplied by the price, and you end up with a negative price. So that's a very old example, and it's been around for ages. The other one that I see a lot, and particularly within web application, is failure to halt execution. So they'll do some sort of check, if this, whatever, then do this, but then on halt execution. And so we'll typically see something like this for authentication. They'll check, is the user authenticated? If they're not authenticated, redirect them to the login page, and then they don't exit after this. So the code doesn't stop running. So you can still access the other functionality within this page without having to be authenticated. Just post it in a curl request rather than directly through the browser, because the browser will redirect. Another one is padding oracles. This one pops up from time to time. There's been a few public examples, but I get the overall feeling that people either don't understand exactly how they work or even what they are. Sometimes when you talk to non-security people or IT people and you mention padding oracles, and it's like, we don't use any Oracle products. It's fine. But it's a cryptographic attack. It has nothing to do with Oracle, the vendor. And it's basically a method where, without knowing the plain text or without knowing the key, you can decrypt as a ciphertext back into an IV, which will let you recalculate the plain text. There's some good examples. The CryptoPals is a great challenge site if you want to learn about cryptography in general. The Skull Security blog is a pretty good write-up of the Padbuster attack, or generic padding oracle. I actually borrowed their example for this. And this basically shows, here we have a small cipher string. It has a 0 value for the IV, which makes it very easy to do the math for this. And essentially what we are doing here is we are bit flipping through the ciphertext, and we end up with a true-false condition out of, the byte range of 0 to 255. And by progressively working through, you can then recalculate IV, you can recover the plain text. It's crypto, it's a lot of math, so I'll try not to get too deep. It's a little bit outside my comfort zone as well, so go read the actual papers who will describe this accurately. All right, next one, race conditions. Race conditions have traditionally been a good method to get privilege escalation within operating systems. There's a few examples on Windows, there's a bunch on Mac, and way more for Linux. There's also some for Android, iOS. Generally, they exist overall. And it's a problem when a process is attempting to access a resource, and you as the attacker can influence that resource at the same time, causing a race condition. So there's a few examples there. The VulnHub one, you can go and try your hand at yourself. But essentially, this is what the code would look like. It first checks if it can access a file, and then later on it opens the file. And it's possible that the file has changed in between the time of check and the time of use. And that's the most common type of race condition, but it's not the only one. So in more recent years, we've also seen race conditions being exploited in web applications, where you can, for example, spawn 1,000 threads that tries to redeem a coupon, and you get maybe the coupon discount 100 times. So it's not just an OS or a local attack. It can be applied elsewhere as well. but we are not seeing as much of that. So it's a slightly forgotten or slightly misused, misunderstood bug class. Information disclosure or info leaks. Again, it's kind of a broad category. I don't consider this to be the OWASP sensitive information disclosure. It's not talking about when you accidentally put your database on your website. That's a different problem. This is gaining access through some technical method to information that you necessarily shouldn't have access to. So a great example is Heartbleed. I think everyone's heard of Heartbleed. The other one that you typically see information disclosure leaks used for is bypassing ASLR. But it can be anything from obtaining administrative plaintext credentials through some hidden backdoor URL, etc. So again, 2 references. Heartbleed has a lot of sub-references, and you can sort of go and read that. But XKCD kind of explained this pretty simply. It's basically the client keeps asking the server, are you still there? Please respond. And you can send a size of the response you expect back. So you say, please reply with hat, but give me 500 letters. So it starts reading from memory, and it reads past hat and into somebody else's message, which could be used to disclose any number of information that's being transmitted over SSL. All right, uninitialized vulnerabilities. Great typo. Uninitialized variables. I'll fix that before we publish the slides. All right, that occurs when a variable is declared, but it's not assigned a value. And at that point, you have undefined behavior if you later try to use this variable. Most of the times, it'll probably just result in a null pointer to the reference or some sort of crash and a null of service. But in other cases, it can result in memory disclosure. In the case of PHP register globals, which is pretty much a dead attack class now, you could use it to basically set any variable to any value that you wanted if it was uninitialized. So you used to see a lot of like authentication bypass leveraging this type of vulnerability. Halvar has a good white paper. Go read that. So he's a C example where the uninitialized variable will read some memory of the stack. So discloses memory without having been assigned a value. All right, directory traversal, also generally an old school attack. I have a bit of a gripe with this, with a lot of the modern day vulnerability hunters who will say that they found a local file include or a local file disclose on a web service or a website, and what they've actually found is a directory traversal. So it basically consists of providing the parent directory identifier, the // into a file path to alter the destination file path. But it's not just useful for things like reading a file or getting a file include. Sometimes you can manipulate the path to a binary or path to an upload directory or essentially customize it to the specific vulnerability. So Marcussen has an example where he had directory traversal as part of the overall attack that would let you install malicious apps or Trojan iPhone over AirDrop. The more recent one that's been going around, Pulse Secure SSL, has a directory traversal that lets you again read files in this case, and you can extract encrypted hashes or plaintext passwords. I believe Orange Sci will be covering this bug. Could be wrong, at 5:30 today, so you might want to go see that one. All right, so yeah, this is the one for the Pulse SSL. This one is from Twitter because the exploits generally tends to try to read etc password rather than some more valuable files. So this is the type of attacks you see going around. In this case, it has some hard-coded string, this doona requirement, and so by mixing that string in with the directory traversal, it bypasses the authentication check. So, all right, security misconfiguration. Again, a very large category. We'll probably often see a lot of complaints about SSL configuration, how secure SSL is. I don't really consider it is a risk, but we haven't really seen people get compromised because they used a lower cipher SSL key or key size than a higher one. Better examples, I think, are things like PHP configuration, allowing URL include, register globals. Again, those particular ones have been set to secure values now by default in PHP, but it didn't used to be the case. Remote file include was running rampant on the internet a few years back. Register globals before that. So some of the ones that I often deal with is Apache hardening. I've done a bunch of research on that in the past. Allow override is a really bad directive. You should never set that to all. You should always set it to none, or at least limited. So again, some examples of that in the links, and a code examples. If you set allow override all, I go and create a htaccess file that reconfigures itself as a PHP script and contains some PHP code. And if I can upload that to a subfolder on your website, I now have code execution. And compiler optimization vulnerabilities, I don't have a specific CWE for this one. Two examples referenced is memsad and null check removal in the Linux TANTAP kernel from a long time ago. But essentially, sometimes when the compiler optimizes code, it will remove code that the developer have written because it meets some optimization rule, and sometimes that is unintended by the developer. It removes a security check, resulting in the compiled binary now being vulnerable, even though the source code explicitly wasn't. So an example from memsad is here, where this is called the dead storage removal. So we are writing to a region of memory, trying to zero out a password that's in memory, followed by immediately freeing the variable. And the compiler goes, well, why do you write to something that you don't use again? We don't have to write to it. We'll just free the variable. Freeing the variable does not zero out the memory, and now your password is retained in memory. So that's an example of the compiler optimizing out a security control that you've inserted. All right, and well ahead of time, actually. Authentication bypass. Again, where I sometimes disagree with the definition, authentication bypass, I would argue, is often a choice of impact, not necessarily a vulnerability class on its own. An example of that is this HP ILO 29A's bypass. That's actually a buffer overflow that corrupts the logged in state. So it's not vulnerability class of authentication bypass. It's simply an impact of exploiting a buffer overflow. So we do lack a little bit of clarity around a lot of our terminology, and it's not just for these. I think overall we don't document or necessarily articulate specifically what we're after, and we tend to very often just put things in a broad category and move on. All right, an example of authentication bypass that you'll probably see in more recent years is the use of JWT tokens, where you can downgrade the algorithm for encrypting the token to none and then just set whatever values you want yourself. So, right. So, what do I want you to take away from this presentation? Go out and learn some more bug classes. When you do assess a product or a web service, you do some research, try to chain the bugs together. Sometimes you have to alter the impact that you're trying to get out of a particular bug in order to do this. So, for example, rather than getting code execution on the ILO interface, you can get administrative access, which gives you greater or easier exploitation of other services. Always aim for maximum impact, so you can really illustrate to the vendor and sort of the users why they need to patch. All right. So, conclusion. The impact of vulnerabilities are not fixed. When you find a vulnerability and you write an exploit, you have typically the choice to choose what you want to achieve as part of the exploitation. Our definitions of bug classes and definitions of vulnerabilities definitely have room for improvement. Quite often the recommendation also have room for improvements. We should not let bug classes become lost. So a lot of the times old vulnerabilities can be brought back and applied to new things such as race conditions and web frameworks. And always keep learning. I want to say thanks to, among many others, these people who all provided feedback on what they consider to be underrated bug classes and why they consider it to be underrated. And that is it for me. So I guess we can take some questions.
That's great. Thank you. A round of applause, please, for Eldar. So Eldar's very kindly donated 2 awesome T-shirts. I'm so jealous for the best questions. So what we get 2 prizes. One, we're going to give out 2 prizes. One for the most upvoted question and one for your favorite question.
Okay.
Okay. So when we have 9 minutes or maybe 7 minutes, any questions from the floor before I go to Slido? No? If not, okay, let's go to the most upvoted question. If you're going to replace one of the OWASP, it was, the typo has been corrected. Good. It was OWASP before. So OWASP top 10 vulnerabilities with one on your list. Which one is it?
If I had to replace... So, I mean, I did have almost top 10 vulnerabilities on the list, including security misconfiguration. So, I think I would probably just leave them and just improve the definitions or add clarity around it, rather than replace one of the OWASP top 10. If I can digress a little bit on OWASP top 10, I think the industry has an unhealthy obsession with OWASP top 10. And I think that sometimes leads to other bug classes not getting enough, time in the spotlight. But I think overall, the biggest problem we have with OWASP top 10 is how we misuse it. And the data is generally collected, and so it's vulnerabilities that are being identified sort of typically actively from various sources. And my opinion, personal opinion, is that OWASP top 10 is usually a reflection of what was considered standard development methods 5 to 10 years ago, and is now actively in production. So I think the data that it represents is the data it represents, but I think maybe we need to remember what it actually represents when we go and say that this is important for whatever reason.
Okay. So who's RB? You win the type. Oh, great. Oh, second prize for you. Awesome.
All right.
You want to give one? Okay.
You want this one, or you want the cat? The skull or the cat? The cat.
Yeah,
all right.
The cat's a cute one.
All right. Congratulations.
Okay. Any other questions from the floor? Not, okay, why don't you pick one? There is another one upvoted. I think then this one will automatically get the prize.
Number 9, yeah.
AG.
just overtook it.
Yeah.
Most overrated vulnerability. I'd probably just have to go with SSRF because it's so widely spread at the moment. And sure, if you can leverage it to access metadata and extract keys and get into somebody's cloud environment, then it is critical. But it only takes such a small amount of control to make it almost a low or insignificant vulnerability. So I think, the proof is in the pudding, but I think as a bug class, it's more of a useful, and we'll probably hopefully see it die out soon. So.
Okay, who's AG? You're supposed to put your full name. All right, come out here and get your T-shirt. And while we're waiting for him to come up here, I think we have another upvoted one. So I do have one more gift from Herdian Nugraha. In your opinion, what would be the most misunderstood point between researcher and developer when defining impact and attack vectors?
I'd probably say that it's trust. So whenever I've had to deal with developers and explaining vulnerabilities, they often don't understand how we did it. They're like, where did this come from? Right? So they think that we have a drop-down box of values on the website. How could you put apostrophe or 1 = 1 in here? Don't do that, by the way, kids. Use and 1 = 1. It's safe injection method. And it tends to be that they think that the technology works this way. This is what we've observed, and we don't necessarily think that you can really go outside of the box by understanding the technology and attacking it that way. So I generally say that the two halves of that conversation comes from very different backgrounds and have very different views on how the technology operates, and that's where I'd say most of the friction comes from.
Okay, where is Herdian? He's not here?
Not here.
Oh, you lost your chance. Okay. I think we have time for one last question. You can pick one, I think, from there.
Yeah, I'll just go with the next one. I think the web scanner dynamic static. The short answer is yes. It is possible. Again, it depends on the capability of the web scanner, and it depends on the location within the application of the vulnerability. So, for example, very deeply nested vulnerabilities in like a 15-step process, the web scanner will probably always fail because it doesn't follow the logic to reach there. Any automatic scanner would typically fail. You'd probably need a human. But if it's something simple like directory traversal in the single parameter to a URL, yeah, it'll find it for sure. So the answer is yes, it can, but it may not always do it.
Okay.
All right.
Does this question deserve a prize?
Sure, if you have one.
Are you here, Ms. Mastur? Oh, not here. All right.
All right. Okay.
Okay, thank you so much.
Thank you for your
Another
time.
round of applause for
if you have any other questions, we have a booth just outside.